Salesforce Apex enforces strict rules around constructor overloading. You cannot cleanly define 10 different optional variants for an object without writing a massive amount of repetitive boilerplate. As your objects grow to include more optional fields, developers are forced into what is known as the telescoping constructor anti-pattern. Look at the left side of this code comparison. To instantiate an account object, we have to pass a long sequence of positional parameters, including forced null placeholders for fields we don't even need. Compare that to the right side, where we have a clean, vertical chain of named methods. Those positional parameters make the code difficult to read. More importantly, if you add a single new required field to that constructor, every call site in your codebase breaks. Relying on these telescoping constructors makes an Apex codebase fragile. Routine business requirement changes turn into manual refactoring operations across dozens of files. The creational Delder pattern provides a structural methodology to bypass these strict Apex constructor limits. As outlined in the research, the core philosophy is to separate the construction of a complex object from its final representation. Instead of instantiating the object directly, a dedicated builder class accumulates the configuration through a series of method calls, then assembles the final product at the very end. Because each method explicitly names the field it configures, the resulting code reads logically from top to bottom. Optional fields are simply omitted. Separating construction from representation allows the developer to move the logic of object assembly away from the call site and into a single dedicated class. To implement this pattern, we rely on 3 distinct building blocks. Look at this diagram. On the left side, we have our first block, the product. This is the empty, complex object vessel being built, like an S-object or a JSON payload. Moving to the middle, we find the builder block. Its primary job is to hold mutable state as we configure the object. Notice that each method call in this loop returns the builder instance itself, the keyword this, instead of returning void. This is the fluent interface concept. By consistently returning the builder instance, we eliminate the need for intermediate variables and enable a single, unbroken chained expression. Finally, on the right side, we reach the third block, the build method. This acts as the ultimate validation gate. It inspects the accumulated configuration and stamps the product as sealed, or rejects it if the business rules are unmet. This final gate is the only place in the entire process where an exception should be thrown. By chaining methods and deferring all validation to the absolute end, we guarantee that the resulting objects are valid by construction without punishing the developer with strict execution ordering rules. Let's apply this to the most valuable use case for an Apex developer: building a standardized test data factory. Standardizing test data at scale relies on the concept of smart defaults. When the builder is instantiated, its constructor automatically seeds all mandatory S-object fields with valid baseline data. They only use the fluent setters to override specific data points relevant to their exact test scenario. Because the boilerplate is handled internally, the resulting test classes remain short and specific to the logic they are testing. Smart defaults decouple the core test logic from irrelevant mandatory data, ensuring tests evaluate business requirements rather than schema scaffolding. Imagine a common enterprise scenario. A new required field, like account source, is suddenly added to the Salesforce schema. Under the old telescoping constructor model, this single schema change would break every test class across your organization. Look at how the builder pattern handles this network of dependencies. When a new field is required, you update the smart defaults in the central builder's constructor exactly once. Every existing test class that uses the builder continues to compile and pass without any modification. Centralizing object instantiation acts as an architectural shock absorber, reducing maintenance overhead and protecting the codebase against routine schema changes. The builder pattern scales beyond state management to encapsulate complex grammar and enforce security protocols. Assembling dynamic SOQL queries via raw string concatenation creates potential vulnerabilities for SOQL injection attacks. We can introduce a specific SOQL query builder class to act as a structural defense mechanism against these threats. Notice how this query builder operates. Whenever a where equals method is called, the builder automatically applies the escape single quotes method internally to sanitize the raw user input. Because this logic is baked into the builder, developers using the class at the call site cannot accidentally forget to sanitize their inputs. Embedding security directly into the class structure provides a systemic safeguard that individual developer discipline at the call site cannot match. As you deploy this pattern, you must choose between two structural configurations, inner and outer builders. This matrix breaks down the ideal use cases. An outer builder is a standalone class. Outer builders are mandatory when working with S-objects, and they make finding and mocking your test data factories easier. Contrast this with an inner builder, a nested class. This structure gives the builder direct access to private variables on the outer class. Because of this internal access, inner builders are specifically recommended for multi-layered DTOs and JSON payloads, where you need to enforce strict immutability. Choosing between an inner and outer builder is a trade-off between organization and strict object encapsulation. Let's address a distinction before wrapping up. The builder pattern is often confused with the factory pattern. A factory decides which class to create based on specific conditions. A builder decides how to configure an instance of a known class. These responsibilities should remain separate. To implement builders effectively, follow two rules. First, mandatory fields belong in the constructor, while optional fields belong in the Fluent setters. Second, never validate data mid-chain. Always defer validation logic to the final build gate to prevent throwing premature exceptions. Using the builder pattern creates a codebase that documents its own intent while physically preventing the instantiation of invalid domain objects.